Work through some of the problems on pages 22-23 concerning rational exponents. Let's take a look at number 16. So we'll do 16 and then we'll do 14. These are translating between radical form, which is what this is, and exponential form, which contains all of this information in an exponent on x. First of all, whatever power of x we're talking about, we are dividing by it. So I know that this number is going to be negative for division instead of multiplication. Then I've got a square root of x to the 5th power. So I could write this as x to the 5th power, and then I'm taking the square root. So those ideas would be contained by one half for my square root, so that's this, and then 5 for the 5th power. In other words, this is x to the negative 5 over 2. Alright, and you can see, okay, well that's x to the 5th to the 1/2, and then it's negative. So here's my x to the 5th, there's the square root of that, and then I could even break this other idea up as, okay, now I'm dividing by that power of x. So, rational form, right here, exponential form, is a really handy way of communicating all of those ideas. How about number 14? Let's go the other way. So in exponential form, 2 to the negative 1.5, and I want to put this into radical form. Well, first, let's translate this into a fraction. 1.5 is 3 over 2. So I could rewrite this as 2 to the 3rd to the 1/2, right? Because that's going to be 3 over 2. And then I'll deal with this negative sign again separately. Right, when I take powers of powers, they multiply, so basically that multiplies out to negative 3 over 2. I'm just breaking up each of those ideas, so that 2 to the 3rd power, the half means that it's actually the square root of that, and then to the negative 1 power means I'm actually dividing by it. So that would be radical form for number 14. Alright, let's move on and do number 24. Number 24, I have 2 times the cube root of 81. Alright, well 81 is 9 times 9, or 3 times 3 times 3 times 3. So I don't have to, but I could rewrite this as the cube root of 3 cubed times 3, right? So I've got those 3 that I'll write this way, just to make it more clear, or obvious. That's a 2. Pardon the squiggle there. My 2 is dancing. We're looking for perfect cubes, because those, if I'm taking the cube root of the whole thing, those simplify down to simply 3. So that's the cube root of 3 cubed. And then my 3 is still, right, that's cube root 3. This is cube root of 3 cubed, which is just 3. In other words, this is 27. That's what 3 cubed is. Alright, so then I have my 2 out there. Then 2 times 3 I can say more simply as 6. and then I've got the cube root of 3. So that's what this simplifies down to be. 24b, I have root 18 over root 25. Root 25 is 5, because 25 is 5 squared. And then the top I can rewrite, so I'm looking for that perfect square, since this is a square root. So the square root of 9 is 3, root 2 is still root 2, and it's all over 5. Okay, this is root 24, A, B, and then let's take a look at C. It's the square root of 12 over 49. Anytime you have the square root of a product or a quotient, I can split that up, because roots and exponents are basically in the multiply domain, so I can look at those separately. The bottom, root 49 is 7. Over here I've got a 4 and a 3. Root 4 is 2. And that is what number 24 simplifies to be. Let's take a look at number 26. I've got root 10 times root 32, and we want to see if that will simplify. So there are two ways to do this. One, I can look at each one separately. That's 5 times 2. This is 16 times 2, which is 4 times 4 times 2, and you could go further, right, into 2's. But if you stop and notice, I've got 2 2's and 2 4's. Then I could rewrite this as root 5 times root 2 times root 4 times root 4 times root 2. And then I can start to simplify. Anywhere I have the same root multiplied together, because this is 4. These two would be 2, and then I'm left with root 5. So then this simplifies down. This is 8 right there, 8, and then root 5. And that would be my answer. Alternatively, you could just take those numbers and multiply them together and say, okay, that's the square root of 320. And then we've got 32 times 10, and you can go on and do that. Or, it's a little bit harder to see, but if I took this, 32 times 2, that's 64, so then I have root 64 and root 5, and that would be 8 root 5. So either way you approach it. Once you find all of those perfect squares and bring them and simplify them, right, there's no sense saying root 4 when that's simply 2, or root 16 when that's simply 4. You can simplify that. Alright, the next one on number 26, got root 54 over root 6. And we can do this two different ways. First, if I recognize that 54 is 6 times 9, I can go ahead and make this, right, kind of the opposite of what we did here, because these are equivalent. The square root of this fraction is the square root of 12 over 49, and likewise here, I could rewrite it as the square root of a fraction, because then I can first simplify in here, and this is, right, the top is 6 times 9, so 6 over 6 is 1, so this is simply the square root of 9 over 1, but I can just write root 9, and so that's 3. If I don't do that, if I simply deal with these two roots separately, here I have root 6, root 9 over root 6. That's the same, so that's 1, and again I end up with root 9, which is 3. Alright, 26c, I've got the cube root of 15 and the cube root of 75. So I'm looking for a perfect cube. You might notice, okay, I've got a 5 in here, and 2 5s in there, so let's see if we can bring those out. Root 5, cube root 5 times cube root 3. I'm splitting up 15. And then the cube root of 25, or 5 squared, times the cube root of 3. So if I combine these two, this is the cube root of 5 cubed times the cube root of, I've got 3 times 3, the cube root of 9, or 3 squared. If it were cubed, I could simplify it, right? But I just have 3 squared, so it's going to stay cube root 9. The cube root of 5 cubed is simply 5. So now this is 5 cube root 9. So that's 26C. Let's do one more. And I've got enough paper just to squeeze it in. If I put part A over here, number 28, I've got the 5th root of 1 over 8 times the 5th root of, 5th root of 1 over 4. I'm thinking about 3 because I recognize that this is 2 cubed and this is 2 squared. So I could write this as the 5th root of 1 over 2 cubed times the 5th root of 1 over 2 squared, which, by the product rule for roots, I can combine these and say this is the 5th root. I can multiply them within a single root. 2 cubed times 2 squared is 2 to the 5th. And the 5th root of that is simply going to be 1/2. So that's 28A. I'm going to go ahead and do B and C for 28. So if you want to, you can continue this video or go on to the next one if you are good with this now. So I've got the 6th root of 1/2 and the 6th root of 128. And again, we can just simply combine them inside one root since we're multiplying. So 128 times 1/2 is 64. Well, 64 happens to be 8 times 8, which happens to be 2 cubed times 2 cubed, which is 2 to the 6th. So then the 6th root of 2 to the 6th is simply, 2. And last but not least, part C. I've got the cube root of 4, right, which is not a perfect cube. I've got the cube root of 108. Well, let's see what's going on here. I can write that as a single cube root, 4 over 108. Let's see if this can reduce. This would be the same as 2 over 54. And let's do it again. Cube root of, you can divide both top and bottom by 2, 1 over 27. Okay, let's see what's going on here. So this is the cube root of 1 over 27 is 9 times 3, or 3 times 3 times 3. And the cube root of 1 over 3 cubed, or 27, is simply 1/3.